Hello, this is take two of circuits. Let's get into it. We have a test next week, I think. Okay, there are three types of circuits. The first one, let's talk about simple. Oh my gosh, I'm going insane. Oh my goodness. Simple slash single circuit. As you may have guessed, that's my light bulb. And this is my battery. You should be following along and taking, you should be following along and taking notes as well, please, so I don't have to explain this 5 million times again. That's a light bulb. Shing, shing, okay, and that's the battery. Now we have something called a series circuit, where, Barbara, stop. Vicente is gonna make fun of me for that. Series circuit, where we have the circuit in a series. And then we have the parallel circuit, where it looks a little bit different, where it goes like this. Oh my god. Oh my god. Oh my god. Okay. Don't mind. Oh my gosh. Okay. Oh my gosh. Okay. She never plays with that toy and she chooses right now to do that. Okay. I know. Okay. That's a parallel circuit, bruh. Now, you need to know these three types of circuits. We're not even getting into anything more complicated. It's literally three things, okay? So you should have those three things written down on your notes, hopefully, please. Now, let's get into some of the differences, okay? If you notice, let's think of these circuits as a grocery store checkout line, okay? Pretend that this is the entrance. We're going and we're checking out. You can go one of two ways here, right? You could go to this checkout person, or you could go to this checkout person. So there are two currents here because you're going to have to pick between either this checkout person or this checkout person. Okay? And then it obviously comes back together at the end. Now, there's some things that we have to think about when we talk about the parallel circuit, because in a parallel circuit, it's different than the simple and the single and the series because it has two different currents here. So let's write down two currents. Now, as a person, can you go into two different checkout lanes at the same time? No, you have to pick one, right? And there's this thing where if one checkout lane, if the cashier is slower than the other one, that means it has more resistance. Slower cashier equals more resistance because it's causing more resistance to the current. Okay? So if I have these two cashiers and one is slower because it has more resistance, then this one would be faster because it has less resistance. So less resistance equals faster. Okay? Now when you think about these two things, how there's two currents, slower equals more resistance, faster equals less resistance. These two currents can have different, how do I say